All right, guys. I thought for this trigonometry word problems con practice, I thought I would just pull the problems directly from the con practices. And so this is what this one says. You have a flag here, and it says Isabel is making a huge flag for her country on a canvas 20 by 10 meters long. To do that, she has to draw a diagonal line that begins at the bottom left corner, so down here in the bottom left corner, and ends at the top side of the flag 6.6 meters to the right. So that's this distance right here. 6.6 meters is right there. Okay? She ends, since the ends of the diagonal line are too far to put a ruler between them, Isabel wants to find the angle of the diagonal and draw it using a protractor. And so what she's looking for is, what is this angle right here? Because her ruler only goes to about right here. And so she can't get that ruler all the way, so she's devising a plan to get a protractor and use that to draw the angle. So she needs to know what the angle is before she can use the protractor. All right, so our variable is here. We want to know that angle. And so what we have to do is we have to know what trig function deals with these two different sides, the 6.6 and the 10. Well, if we look, that 6.6, if we go this direction, that's opposite the angle. And this 10 is adjacent. So we have opposite and we have adjacent. All right. So what trig function deals with O and A? That's tangent, the TOA part. Okay, so what we would say is the tangent of x is equal to the side opposite divided by the side that's adjacent. All right, and so if we have tangent of x is equal to 6.6 divided by 10, we're trying to isolate x, so we have to get rid of the tangent function. So in order to do that, we have to do the inverse tangent of the tangent of x, and then we have to do the inverse tangent of 6.6 divided by 10. And so what happens here on the left side is this inverse tangent and tangent cancel each other out, so I just have x is equal to, and then I'm going to have to plug this 6.6 divided, or inverse tangent of 6.6 divided by 10 in my calculator. I'm going to do that real quick. My calculator gave me 33.4248 degrees. I'm going to put that many decimals because I'm not exactly sure what the con practice is looking for. And if I go back, it says round your final answer to the nearest tenth. So that's to the 4. We look at the 2. It's not going to affect the 4, so my answer is 33.4 degrees for that angle measure in the flag right here. And all right, here's the picture of the second problem. And I'm going to read you what it says. Archimedes went to sleep beside a big rock. He wanted to get up at 7 a.m., but the alarm clock was yet to be invented. He decided to sleep at the spot where the rock's shadow should end when it's 7 a.m., so as to be awakened by the direct sunlight. Archimedes knew that 7 a.m. the sunlight reaches the ground at an angle of 31 degrees. The rock beside which he slept was 5 meters tall. How far from the rock did Archimedes go to sleep? Okay, so if we look right here, this is supposed to be where Archimedes went to sleep, right here. So he slept right here. Here's the rock. And here's the sun way up here. Well, let's give ourselves a yellow sun, not a black sun. All right. And then we have a shadow right here. And what we're trying to figure out is how far away from the rock. So what is this distance right here that he slept? Okay, we're going to call this x. All right, so again, what we're looking for is, this rock is 5 meters, or 5 meters tall. So this side is what in relation to the 31? And this x is what in relation to the 31. Hopefully you know that this is opposite the angle 31, and this is the adjacent side to the angle 31. And so what we want to do is we want to say opposite and adjacent, that's tangent. So the tangent of 31 is equal to 5 over x. Our side opposite divided by our adjacent side. Now if I solve that for x, I should have the distance from the rock to his sleeping position. So tangent of 31 is 5 over x. Let's solve that again. We got to get the x out of the denominator. So we have x times the tangent of 31 equals 5, because my x's are going to cross out. And then I'm going to divide both sides by the tangent of 31. Excuse me. And so in my calculator, I'm going to type in the 5 divided by the tangent of 31. And when I do that, my answer is 8.321, and it asks us to round our answer to the nearest hundredth. Now be careful. On the last problem, they said to round to the nearest tenth. So you really got to watch out for what they're asking for. They're going to switch between tenths and hundredths as your answer. So here's my hundredth spot, and that one after it will not affect it. So he slept 8.32 meters from the rock. Question number 3. Here's what it says. Barbara is building a wooden cabin. Okay, now, if my picture is not obvious, these are supposed to be like cabin logs. Okay, so my drawings aren't the greatest, but that's what it's supposed to be. The cabin is 42 meters wide. So that's down here at the bottom, 42 meters wide. She obtained a bunch of 27-meter long wooden beams for the roof of the cabin. So that's these right here. This right here is the 27-meter long beams for the roof. Naturally, she wants to place the roof beams in such an angle that each pair of opposite beams would meet exactly in the middle. What is the angle of elevation in degrees of the roof beams? Okay, now if we don't know what an angle of elevation is, an angle of elevation is from the horizontal, kind of the horizontal plane, the angle of elevation is kind of moving up, and then that angle right there. This is the elevation. The angle of elevation. Okay, so they're looking for this right here. We'll call that theta. That's a common variable to use for angles. All right, we also know that this is exactly in the middle of this cabin. So what that means is I could actually erase that 42 and say that this is 21 and this is 21 just by dividing it by 2. Which also means that this length from here to here is also 21 meters. Okay? And so what we're trying to figure out is what is this angle right here that we have to set the log so that the roof has the pitch that we want and that it meets right here in the middle of the roof. Okay? So we have this angle right here, theta. What is 21 in relation to that angle, and what is 27 in relation to that angle? So hopefully we know that this is adjacent. That's the side adjacent to that angle. And this is the side that's the hypotenuse. So we have A and we have H. So we're going to be using, here's my A, here's my H for adjacent and hypotenuse. So we're going to be using cosine. So the cosine of theta is equal to 21 over 27. All right? And so what we need to do is solve for theta. So I'm going to move kind of down here. We're going to do the inverse cosine of the cosine of theta because we're trying to cancel out that cosine of theta. And we have to do the same thing here. So on the left side we have inverse cosine and cosine. Those undo each other, cancel each other out. And so we have that theta is equal to the inverse cosine of 21 over 27. And so I'm just going to use my calculator here. Now, one thing to keep in mind is make sure that you're in degrees when you plug in this into your calculator. There's a setting that's DEG on your calculator. Hopefully, it should, most of the time it's set to that already, but make sure it's on degrees, because that's what your answer is asking for, is what is the angle of elevation in degrees of the roof beams. So I'm going to plug that into my calculator right here and get an answer. So my calculator gave me an answer of 38.9 degrees. So that's the angle at which they need to set these roof beams to get the pitch they want. All right, the last problem reads like this. Alexa's friend got her skydiving lesson for her birthday. Her helicopter took off from the skydiving center, ascending at an angle of 20 degrees. So that's this angle right here. And traveled a distance of 3.4 meters. So that's the hypotenuse of this right triangle, before she fell in a straight line perpendicular to the ground. So she's going this way. She gets dropped off right here and falls straight down. How far away is she from where the helicopter took off? So she lands right here. And this is the takeoff location. We want to know how far away is she from the takeoff position. So again, we're looking for what is the relationship between the side and the hypotenuse with this angle right here. So this x is the side that's adjacent, and this is the hypotenuse. And so we're going to use cosine again. The cosine of 20 is equal to the side adjacent, x, divided by 3.4. This one's pretty easy. We're just going to multiply both sides by 3.4. And it will basically reduce, or it'll cancel out that 3.4 on bottom, and then we'll just have x. So we're going to plug that into our calculator and see what we get. All right, so when I plug it in my calculator, I get 3.19 is equal to x. So she is 3.19 kilometers away from her starting position where the helicopter took off. Make sure also that you know that this answer should be rounded to the nearest hundredth. All right? If you have questions, let me know, but that's 4 different problems that you're going to be looking at with this con practice. Good luck, and email me if you have any questions.